Welcome to Divya Forensics. Here we explore the world of forensic science from crime scenes to laboratory analysis and the science behind every clue in a way that's simple, clear, and exciting to learn. If you are curious about how evidence reveals the truth, you are in the right place. Let's dive in. Your learning journey starts now with Divya Forensics. Today we are starting an exciting new series on the forensic science. Forensic science is the backbone of modern criminal investigation. But have you ever wondered how did it all begin? Who were the early pioneers? And how did simple observation evolve into high-tech crime-solving methods we use today? In this first class, we are going to explore the origins of forensic science from ancient civilizations to the first scientific developments that changed the world of criminal justice. Now we are going to learn about the history of forensic science. Forensic science has a long and interesting history. Let's begin by understanding what forensic actually means and how the field developed over time. Forensic terminology. The word forensic comes from the Latin word forensis, which means of the forum. In ancient Rome, the forum was a place where legal trials and public debates were held. So, forensic science basically means science used in courts and legal discussions. Various types of definitions of forensic science written in the different books. But simply, forensic science is the application of scientific methods to law and justice. This includes identifying, analyzing, and evaluating physical evidence found at crime scenes. It is also called criminalistics. In simple terms, forensic science is nothing but applying science to solve crimes. Coming to the nature of forensic science, it is an applied science that helps to fight with crimes. Its main purpose is to provide accurate and objective scientific information to the court. Forensic scientists help to recreate what had happened at a crime scene using scientific evidences. The scope of forensic science is very wide. As society becomes more complex, crimes also becomes more advanced. So forensic science works closely with criminal law and civil law, helping investigate everything from theft to murder to cybercrime. Origins of forensic science. In ancient China, Song Shi wrote the world's first forensic science book. He described methods like determining cause of death, using insects to detect murder weapons, and in ancient India, the Arthashastra included early forensic ideas like fingerprint like identification, examination of wounds. And in ancient Rome and Greek, they have used early medical examinations and poison detection. In Middle Age, Middle Ages to Renaissance, 1200 to 1700, important developments of forensic science had begun. Doctors began doing autopsies. Courts slowly accepted scientific evidences. Early document examination was started. This was the beginning of applying science to the crime. In 18th century, it is the foundation of modern forensics. Carl Scheele discovered a method for detecting arsenic poison, a major moment in toxicology. First use of physical evidence in solving a crime. It was happened in 1784 in England. This marks the start of scientific crime solving. In 19th century, rapid development was seen in forensic science. Herschel, Galton, Juon developed fingerprint systems, and Matthew Orfila studied poisons and their effects on the body and became father of the forensic toxicology. This was a time of major forensic breakthroughs. And Alphonse Bertillon used body measurements to identify criminals. Autopsies became more common. Shows the shift toward physical identification and scientific autopsy. In early 20th century, modern forensics emerges. Here, blood groups by Karl Landsteiner, ballistics by Calvin Goddard, Documents by Albert Osborne. First forensic lab by Edmond Locard. This period formed modern forensic tools and labs. And in late 20th and 21st century, DNA fingerprinting by Alec Jeffries, computer and digital forensics, FIS, CODIS, modern tools like 3D reconstruction, AI, facial recognition, forensic science became technology driven and extremely advanced. Coming to the history of forensic science. The roots of forensic science go back to ancient times, but it developed rapidly in the 19th century. Sherlock Holmes, the fictional detective created by Sir Arthur Conan Doyle, played a big role in popularizing scientific crime investigation. His stories introduced methods like fingerprint study and blood analysis even before they were commonly used. Alphonse Bertillon is known as the father of criminal identification. He created a system called anthropometry, which used body measurements to identify criminals. He also standardized criminal photographs and created the first police identification bureau. And Francis Galton is called father of fingerprints. He conducted the first scientific study of fingerprints and proved that fingerprints are unique to every person. His work helped introduce fingerprint classification. Edmond Locard is known as the father of modern forensic science. He established one of the first forensic laboratories and proposed the famous Locard's exchange principle. Every contact leaves a trace. This principle is the foundation of all forensic investigations today. And Paul Crick. Paul Crick was a leading forensic scientist known for his work on bloodstain pattern analysis. His book, Crime Investigation, explained how blood evidence can reveal what happened during a crime. Matthew Orfila is the father of modern toxicology. He developed scientific methods to detect poisons in the body which are still used today. Karl Landsteiner. He discovered blood groups in 1901. This made blood matching possible. Dr. Leone Lattice later developed a method to determine blood groups from dried blood stains, which became an important forensic tool. Hans Gross wrote one of the earliest books on criminal investigation, combining law and science. He emphasized the importance of scientific methods in solving crimes. Kelvin Goddard. He is the father of ballistics. He developed the comparison microscope to compare bullets fired from guns. This allows experts to link a bullet to a specific weapon. Albert Osborne. Albert Osborne is the father of question document examination. He developed principles for examining handwriting, signatures, and documents used in court. This is the overall view of the history and development of forensic science from 19th century to 20th century. Now, let us come into the fundamental principles of forensic science. Law of individuality. Every object is unique. Natural or man-made has an individuality which is not duplicated in any other object. It is unique. For example, fingerprints. Law of exchange. Every contact leaves a trace. When a criminal comes in contact with the object or person, a cross transfer of the evidence occurred is known as Locard's exchange principle. For example, foot and footwear impressions, tire marks, dust, paint, soil. Law of progressive change. Everything changes over time. Nature, which are not always available, like body fluids, which contains body cells, which has unique DNA profile. The scene of occurrence undergo rapid change. For example, the weather, the vegetable growth, and the living beings, especially human beings, make extensive changes in comparatively short period. Longer the delay in examining the scene, greater will be the damage. Law of comparison. Only similar things can be compared. It emphasizes the necessity of providing like sample and specimen. For example, evidence such as bullet, cartridge, firearm, hair, question documents, etc. Law of analysis. Good results depend on good samples. The analysis can be known better than the sample analyzed. The principle emphasizes the necessity of correct sample and packaging for effective use of experts. Improper sample contamination renders the best analysis useless. Example: paint, soil, blood stains, cement stains from crime scenes should be packed and sampled perfectly. Law of probability. Evidence is evaluated using probability. Any act by law of probability results in various chances. Probability is equal to number of events or ways divided by total number of events or ways. Law of circumstantial facts. Facts are more reliable than oral statements. Facts do not lie. Men can do. Hence, the importance is as good as oral evidence. For example, oral evidence depends upon so many factors such as power of observation, assimilation, autosuggestion, external influence, etc. Whereas factual evidence is free from these infirmities. And here is a flow chart of principles of forensic science. Now, let us go through branches of forensic science. Forensic toxicology, study of poisons, study of the presence of toxic substances inside a body. This branch of forensic science is of prime importance in poisoning. Forensic psychology, criminal behavior. Application of forensic psychology to legal and criminal matters. Forensic psychologists study criminals and their crime to draw conclusion about the personality traits of the perpetrators and thus assist in criminal profiling. Forensic pathology. It is a study of autopsies and the cause of death. Branch of forensic pathology that deals with the examination of a corpse to determine the cause of death. And forensic odontology. It is a study of teeth and bite marks. And forensic geology. Forensic geology or geoforensics deals with the examination of evidence related to materials found in the earth such as oil, petroleum, minerals, soil, and rocks. Forensic linguistic. The application of linguistic knowledge and methods to criminal investigations and judicial proceedings. Linguistic experts are skilled at analyzing the written and spoken language of a perpetrator. And forensic entomology. It involves the application and study of the biology of insects and other arthropods. Due to presence of such organisms in decomposing rains, forensic entomology is primarily used for death investigation, determining of the location of an incident. Forensic engineering. Application of engineering principles for the investigation and analysis of such mechanical and structural failures. Forensic biology. It involves the divisions forensic serology and DNA profiling. Forensic chemistry. It involves the divisions toxicology, narcotics, explosives, etc. Forensic physics. It involves the divisions like forensic ballistics and involves the analysis of any evidence related to firearms like bullets, bullet marks, gunpowder residues, etc. Forensic botany. It is the study and examination of plant-based evidence for criminal investigations and for answering other legal questions. Forensic anthropology. It is the study of examining human bodies and skeletons to help identifying the individuals and arrive at cause of death. Digital forensics. It involves the extraction and analysis of digital evidences such as those found in computers, hard disks, USB drivers, etc. It is mostly used in the investigation of cybercrimes. These are the several branches of the forensic science like forensic pathology, anatomy, histology, toxicology, odontology, engineering, physical matching, general careers, critical thinking and psychology, language arts, social studies, law, forensic history, and mathematics, measurements, algebraical expressions, and forensic zoology, minerals, soil, and forensic physics, blood spatters, and chemistry and biology. And coming to the digital forensics, it is also having subdivisions like network forensics, mobile forensics, live forensics, database forensics, and computer forensics. This concludes our lesson for today. I hope you learned something valuable. Make sure to subscribe and turn on notifications so you don't miss the next lecture. Thanks for watching. The notes of this lecture have been prepared from reference books. If anyone interested can access them through the link in the description. In the next lecture, I'll provide MCQs related to these notes and the lecture. So don't miss it. So make sure to stay tuned to my channel.